Let's go through the basic idea of the analysis of variance table in simple linear regression. In particular, we're going to talk about the sum of squares column. To illustrate, I'll use the skin cancer mortality and latitude data set. And first, I'll fit a simple linear regression model. And actually, I'll draw the fitted line plot first. So mortality on the vertical axis, latitude on the horizontal axis. And there's the fitted regression line with equation given up here. And what I'll also do is I will fit the regression model using the fit regression model tool. And I'm going to use basic tables to display the results. And I'm going to store fitted values and residuals. And here's my analysis of variance table. And I'm going to talk about this column here, which is labeled adjusted sum of squares. And I'm going to talk about how each of these three numbers is calculated. And this is to illustrate where these numbers are coming from in a practical analysis. Because the software just gives you these numbers, you wouldn't calculate them from hand, but it's useful to see where those numbers come from to understand them and put them in context. So the first number I'll talk about is the total sum of squares, which, according to this analysis of variance table, is 53,637. So how was that calculated? Well, let's look at this illustration. And here I've got just a generic image of a simple linear regression model. And I've fixed a particular value of x, and I've got 3 points marked. This is the actual data value up here, the top one. So that's yi. The value on the regression line is y hat, given by the fitted regression equation. And then this value down here is y bar, which is the sample mean of the response values. And this dashed line here is just a reference line that's been added to the graph at the value y equals y bar. So let's look first at the differences between y and y bar. If I take that difference and square the difference, and then do that for all the observations in the sample, and add those squared differences up, I get the total sum of squares. So let's actually do that. So what I need to do over here is I need to add a new variable to my spreadsheet, which is going to be equal to the mean of the response variable mortality. There it is, 152.878. And let me copy that cell. And then I'm going to paste it into that column. There we go. Okay, and then I'll use the calculator again. Only this time I'm going to calculate the square of y minus y bar. Okay, so y is this variable. And then I'm going to subtract y bar, the variable I just created, and then I'm going to square that. Okay, so there's the variable I just created. And then if I calculate basic statistics for that new variable I just calculated, if I make sure that sum is checked here, I'll be able to see what the sum of those squared differences is. And it comes to 53,637. So let's just check our analysis variance table. So there it is, 53,637. So that's where that number is, how that number is calculated. Okay, let's do the regression sum of squares next, 36,464. How is that calculated? So coming over to our diagram over here again, that's these differences here squared and added up. So in particular, we've got y hat on the regression line, y bar, and if I square those differences and add them up over the whole sample, I get the regression sum of squares. So let's do that. So I'm going to have to calculate another variable. So this one is going to be the square of y hat minus y bar. And y hat is this variable here. Remember, when I fit the regression model, I asked Minitab to store the fitted values, which is y hat. And then we do a basic statistics calculation for, oops, let's try that again. There we go. And the sum of those squared differences is 36,464. Let's just check our analysis of variance table, 36,464. So that's how the regression sum of squares is calculated. And then finally, the error sum of squares, 17,173. Let's go to our diagram over here again. And let's look at these differences. So it's the difference between y and y hat. So there's y, that's the observed data value. Y hat is on the regression line. If I take those differences, square them, and add them up over the sample, I get the error sum of squares. Sometimes you'll see this referred to as the residual sum of squares, because these differences between y and y hat are called residuals. And they are estimated errors. So you'll see both terms used, error sum of squares, residual sum of squares. It's referring to the same thing. So let's do that calculation. So this one is going to be the square of y minus y hat. And so remember y, that's my response variable. And then y hat is my fitted value. Okay, and then if I calculate descriptive statistics for that, I get a sum of 17,173 for the error sum of squares. And let's just check my analysis of variance table. So there it is, 17,173. Okay, I could have actually calculated that a little bit differently by doing the following. Okay, so y minus y hat, also known as the residual. Okay, and we asked Minitab to store the residuals when we fit the regression model. So if I square these, I should get exactly what I got in the previous calculation. Oh, well, you couldn't quite see it because I gave it the same name. But these numbers didn't change. Okay, it's because you can calculate it either way, it's the same thing. Okay, so that's how these numbers in the sum of squares column of the analysis variance table are calculated for simple linear regression. And in the next video, we'll talk about how these other values are calculated in the analysis of variance table. the degrees of freedom, the mean squares, the F value, and the P value.